This video is for section 13-6, Applications of Geometric Series. We'll do a few example problems together. Recall the recent problem where a relative gives you 1 cent on the first day of January and then doubles it every day for 30 more days. In that question, we asked how much money was earned on the 31st day of January, and it was a large amount of money. Now this question is, what is the total amount of money you receive in the month of January? So this time it's asking us to sum the money earned from all 31 days. To do this, let's use the sum formula. S sub n equals a minus a times r to the n over 1 minus r. The month of January has 31 days, so we want to find the sum of 31 terms. The letter A refers to the amount earned on the first day. That's 1 cent, 0.01. Then we have the letter A again. And then we have R, our ratio. The situation was doubling the money, so R is 2. The letter N is 31. And in the denominator, 1 minus 2. Take a calculator and type in this expression. When I typed it in, I was careful to input the numerator and then press enter to figure out what the top number is, and then I divided by -1. The result is an amount of money, so here's the dollar sign, and then 214,74836.47. From the decimal point, you can go 3 spots, do a comma, 3 spots, do a comma. Our total money is $21,474,836.47. Next example. The diameter of each successive layer of a wedding cake is 2/3 the previous layer. If the diameter of the first layer of a 5-layer cake is 15 inches, find the sum of the circumferences of all the layers. So let's make a quick sketch of the cake from the side. Here we have the first largest layer, and then we have the next layer. It is only 2/3 as long. Then we have the third layer, the fourth layer, and the 5th layer, the cake topper. We're told that the largest distance is 15 inches, and that each smaller one is only 2/3 as much as the larger. Our question is about finding the sum of the circumferences. So besides envisioning the cake, we need to know the circumference formula. Circumference of a circle equals pi times the diameter. So the largest cake layer has a diameter of 15, but its circumference is 15 pi. If we write out the series we're interested in, we have 15 pi. Then the next one is 2/3 of that. So 2/3 times 15 pi. The third layer is 2/3 of that. So 2/3 of 2/3, 15 pi. And so on for 5 layers. Well, instead of writing this all out and getting these fractions that keep building up on each other, let's use our formula. The sum of n terms is equal to a minus a times r to the n divided by 1 minus r. And for this cake problem, we have 5 terms. The first term is 15 pi. 15 pi again, and now the letter r. Our ratio is 2/3. For the letter n, 5. And in the denominator, 1 minus 2/3. Take a calculator and type in this expression. Again, you should type the top in first and push enter, then divide by the denominator. When typing the numerator in, using 3.14 for pi, it makes 40.9. And then divide by 1/3. The result is 122.7 inches. And the last example. In a certain credit union, money left on deposit for 1 year earns 4% interest at the end of the year. If you invest $100 at the beginning and did not withdraw the interest paid at the end of the year, how much would you have on deposit at the end of the 10th year? This is not exactly the same kind of compound interest problem that we had in a different chapter, because it says we're investing $100 at the beginning of each year. In that previous chapter, when we used the compound interest formula, we only made one principal investment, and then it earned interest for however many years. This time, we're putting $100 in every year. Let's model this situation and use a chart to keep our work organized. So we'll keep track of the year, and we'll keep track of the amount in the account. After 1 year, how much money will be in the credit union account? It will contain the $100 that we deposited plus the interest that's earned. There's a 4% interest rate, so to find that interest, 0.04 times 100. 4% of 100 is $4, added to the 100 is $104. After 1 year, there's $104 in the account. Now let's figure out how much money is in there after the second year. It will contain the $104 carried over from the first year, plus $100 more that we deposit, plus the interest. And the interest is going to be 4% of $204. Do you see where the 204 comes from? The 104 plus the extra 100. On a calculator, we can figure out what this makes. It's $212.16. Now let's figure out for the third year. $212.16 is carried over, plus we deposit another $100 during that year, and we're going to earn interest on that money. 4% of $312.16. Again, type that in a calculator, see that total. It is $324.64. Now do the fourth year. $324.64 is carried over because we've never taken money out of the account. Plus, we put another $100 in. And at the end of the year, we're going to earn interest on that money. 4% of $424.64. Take a calculator and type that in. The result is $441.63. Now the fifth year. The $441.63 is carried over, plus another $100, plus the interest earned. There's now $563.29 in the account. We're only to year 5, and we want to find the answer after the 10th year. So we need to keep going with this technique. If you keep going, by the time you get to the 10th year, the total amount of money will be $1,250. Let's think about that value. Of the $1,250, $1,000 of it was money that we deposited because we were doing $100 every year for 10 years. That means that $250 of it was money earned as interest from the credit union. Let's compare that to the compound interest situation from the earlier chapter and consider the situation where we make one principal investment of $100 and earn 4% for 10 years. This time we would use the formula amount equals $100 times 1 plus 0.04 divided by 1 to the 1 times 10. When you use a calculator to type this in, you get $148 So no doubt it's obvious that you'll have a lot more money in 10 years if you're able to put in $100 every year than if you only put in $100 to start and then leave that alone for 10 years. Let's also consider a situation where you deposit a much larger amount of money initially and then leave it alone for 10 years. Let's say that you somehow get $750 and you put that into an investment that pays 4% interest for 10 years. How much is that worth? That's $1,110. That is less money than our situation where we put in $100 every year and let the money grow. So the lesson from that is, if you want to build up a chunk of money for the future, for example, to save for retirement, the best technique is to deposit some money every year. Don't just start with a large chunk and let that grow. It's more important to regularly deposit money into your retirement account every year.